Today's video will discuss Chapter 6A, Systems of Inequalities. Similar to systems of equations, we're just going to be solving a problem that looks like this. Keep in mind that this now is what makes it inequality instead of an equation. These are both in y equals mx plus b form. Obviously, it's not an equal sign, but we can now create a line from that. So we're going to take a look first at this that top equation. Y is greater than negative 2x plus 1. We're going to take this, we're going to put it on the graph, keeping in mind that this is my slope and this is my y-intercept. So if my y-intercept is at 1, that's here. We'll make this the green line. Okay, the slope is negative 2, so I'm going to go down 2 and over 1, which will put me to here. I'm sorry, down 2 and over 1 put me here. I'm looking at backwards. Right, and then I got to go down 2, over 1, so 1, 2, and then over 1, which would put me here. Sorry about that. Forget about that. I apologize. I'm looking at it upside down. So I'm going negative 2 as my slope, positive 1 as my y-intercept. This tells me that because it would be open circle on a number line, this should be a dotted line. So if you remember then, that means that we're creating this as a dotted line. Right, and those arrows make sure that they say that this thing is going to go on forever. So there's the graph of that top equation. So that's the graph for this. Now let's take a look at this. Y is less than or equal to x plus 3. The slope is the number that's in front of the x, the m. Right, so this is a 1, which is the same as 1 over 1. And then 3 is my y-intercept. So I'm now going to come to 3, 1, 2, 3, which is here. Put my circle there, my first dot there. Remember, from here, I'm going up 1, over 1, which would put me here. Go up 1, over 1 again, put me there. All right, so these would be my points for that. Again, x plus 3. The less than or equal to tells me that it needs to be a solid line, right, because it would be a closed circle on a number line. So this now is a solid line going like this. Now, the question is, how do we figure out what is true? Because remember, in system equation, it was what point made both of them true. So we're looking at for what point to make both of these statements true. So let's start with the top equation. Again, I'm going to use the origin as my point of reference. So I'm going to substitute a 0 in for y and a 0 in for x. And I'm going to figure out if this statement is true. 0 is less than, this becomes, or I'm sorry, is greater than, negative 2 times 0 is 0 plus 1, so this is 0 plus 1. 0 is greater than 1. This statement is not true. 0 is not greater than 1. So as I'm looking at this top equation, remember that was my green line. As I'm looking at this, that means that this point here is not true. So I'm going to end up shading everything on this side, and I'm purposely just going to put a couple of arrows here so that I know which side I'm supposed to shade. I don't want to shade it yet because I need to figure out am I supposed to shade which side of the red I'm supposed to shade on. But I now know that everything on this side is not true. 0 is not greater than 1, which means all of that side is, if you remember the shading of the graphs we did before. Now let's figure out for the second equation, right, that red solid line, I'm going to also use the origin, that's 0, 0. Right? So this becomes 0 is greater than, or is less than or equal to 3. This statement is true, so that means that 0, 0 is part of the shaded region. So I'm now going to make some arrows going this way. Now I'm looking for where are the arrows both pointing in the shaded region. So in other words, all of this side is shaded from the green, and all of this side is shaded from the red. But you'll notice, for example, this, let's go up here, this area right up here is shaded in the green, right? The green is saying we should shade there, but the red is not shaded, so that's only shaded by the green. Over here, neither of them are true. Here, the red is true, but you'll see the green is not, so what I'm shading is this area in here. Right? Because now the green shades this side, the red shades this, so this side, or this is what is shared. So keep in mind that oftentimes you're getting this x, and so you're trying to figure out which of the 4 areas should be shaded in the x. right? Remember which sides are not shaded. Again, to determine what you should or should not shade, you can often use the origin, right? You're looking to see if this is true. When it's true, you shade the side that is true, right? Or you shade the side that 0, 0 is on. When it's not true, you shade the opposite side, right? So this one shaded 0, 0. This one, because it was not true, we did not shade the side that had 0, 0. Just be careful what it is that you are or are not shading. And again, I wouldn't start shading first. I would do these small arrows so we could start to figure out what should or shouldn't be shaded. All right, I just have this one example for you today. Thank you for watching the video. Go ahead and give the problem on the bottom of the page a try. We'll try to grade it together in class. Again, thanks for watching the video, and I'll see you in class.